Number 34. Now the electrons are so close together that they repel each other and stop gravity from making the star become smaller. So this is what eventually stops the star from collapsing any farther. 35. The crushed core of the sun is now made mostly of carbon and will now be called a white dwarf. Does not need to be capitalized. 36. Around the core, the outer layers are gently blown away. Notice it's not an explosion. This is not a supernova. It ends up forming something called a planetary nebula. It has nothing to do with planets. All right. Now let's talk about the death of large stars. Not extra large, just large. So after the red giant phase on this one one is able to fuse carbon, unlike our own sun. It will continue to fuse into newer and bigger elements until it starts creating the element iron. Now the chemical symbol for iron is Fe, if you ever see that. The end is now near. The fusing of the element iron requires energy. Instead of giving energy in the form of explosions we've seen, it actually requires energy to be put into it. So it does not release energy and instead just takes it in. So the fusion explosions are dying down completely. Gravity now dominates and the star collapses very quickly, perhaps less than a second, they say. As it comes in, there's a rebound and it goes out. And that is going to be called the supernova. The outer layers are exploded into space. However, the core, now think about this, if you're in the core and there's an explosion outside of you, that explosion actually crushes you if you're in the middle. So the core of the star continues to collapse, and that's what's going to create these crazy things. The core will continue to collapse until the atoms at the core, the protons, merge with the electrons. So the plus things combine with the electrons. Remember, in our sun, the electrons actually repelled each other and stopped it from collapsing. Here, it's big enough that it just crushes them. The electrons are pushed into the protons in the nucleus, and the protons and electrons combine and make neutrons. So all we have is neutrons in there in the core. That's why, logically, the core is known as a neutron star. This is one of my favorite facts. If the core was spinning when it was collapsing, just like an ice skater pulling in his or her arms, the spin gets faster, so it will increase as it becomes smaller and smaller. 45, the spinning core can produce and emit radio waves, so we've set up now something called a pulsar. The object is now called a pulsar. Now if it's not spinning, it's just called a neutron star, but if that neutron star is spinning, it sets up something called a pulsar. Alright, now the death of the absolute biggest things. And that would be the biggest stars in the universe. This star will keep collapsing past the neutron star, so it crushes the electrons past each other, it crushes into a neutron star, but it doesn't even stop beyond that. And it becomes something we know as a singularity. The singularity will create a black hole around it. So the core has been crushed so small that it's smaller than anything we can see, but it's still the mass of many suns. So there's an immense amount of gravity. That scenario will set up a black hole. The edge of the black hole is known as the event horizon. The black holes destroy matter. They usually give off lots of things, but we're going to say X-rays here and for our test purposes. 52, black holes bend both space around them and the time, because space and time are interwoven. We're going to see some crazy things with that on the next page. The bending of light around a black hole can cause a gravitational lensing effect. Now usually when we've talked about the lensing effect, we've talked about supermassive black holes, the ones in gravity, and the one in the middle of galaxies rather. But normal black holes made from stars can do it as well, it's just to a lesser extent. Alright, we'll continue on the next page.